everybody. Today we're going to be doing section 9.4, which is on the increase in greenhouse gases. The learning objective for today is that you can identify some of the threats to human health and the environment posed by an increase in greenhouse gases. We're going to talk about some of the global climate change that occurs from these increases, what it does with like rising sea levels and disease and kind of a lot of that stuff. So first of all, let's talk about why sea level is rising because of keep in mind, we have these greenhouse gas emissions that we just talked about in our last section of notes that end up trapping and then radiating more of this heat back to Earth, which slowly makes Earth a little bit warmer over time. So this then is going to result in increased sea levels. So why is that? The first is because of thermal expansion. Water molecules move slightly further apart when they're heated. Think of the fact that the molecules start moving more, and so they end up moving slightly farther apart. Now, when you have all of the molecules in the ocean moving slightly farther apart, that's going to result in rising sea levels. Now, the other side of this that we have is the melting polar and glacial ice. So at the poles, we have this ice because it's cold, but as things get warmer, it's going to have a warmer climate, and we're going to have more melting of these ice sheets at the poles and then also in glaciers. So this water is going to flow into the ocean and leads to sea level rise. So between thermal expansion and melting ice, that is going to result in increased sea levels due to, again, this warming climate from greenhouse gases, where we're releasing more greenhouse gases, trapping more of that heat or radiating it back, and therefore the temperature increases. So if you look at this diagram here, this is going to be kind of talking about the contributors to global sea level rise between the early 90s to 2018 is when this one ended. So if we're looking at kind of the sea level rise, this purple part is going to be talking about like the thermal expansion. The blue part is going to be talking, the purple part is where you have added water and thermal expansion. Blue would just be the added water on its own for melting ice. Red would be the thermal expansion. So when you put those together, red plus blue gives you purple. So when these both come together, this is what is going to be causing our global sea level rises. So what are going to be some of the environmental impacts of this sea level rise? Well, the first is going to be flooding of coastal ecosystems, such as estuaries that are usually this buffer. The mangroves, the salt marshes, and so you're going to actually have flooding into these areas. So what were kind of this submerged, you still have a lot of plants, a lot of it is going to be underwater eventually. Now, this is going to be a bummer for the species that depend on these environments. We're going to lose those species because they're no longer going to be in a habitat where they can strive. So they're either going to have to move their way inward or they are going to not survive. Now, the human impacts, first of all, we're going to have to relocate all of the coastal human populations. If you look at this diagram here of the eastern United States, everywhere that is very red is areas that have a very high likelihood that they're going to be vulnerable to sea level rising. Orange is kind of moderate. Yellow is low, but like still existing. And so if we kind of look at some of these big like Miami, Virginia Beach, New Orleans, these are things that can potentially be underwater in the future as we have these sea levels rising. So all of those homes and people and businesses, they're all going to have to be relocated so that they aren't underwater. Now, this is also going to increase the flood frequency, which means you're going to have higher insurance and repair costs and loss of property because as you're getting more of this rising level encroaching, you are going to have more flooding occurring even farther inland than we typically have seen in the past. You're also going to get saltwater intrusion, which is where the salt water, the ocean, starts pushing into groundwater and it contaminates wells where some people get their drinking water from wells. So if your well water is salty, you can't drink it. You no longer have drinking water at your home. Now we're going to have these people who are going to have refugees are just people who are forced to relocate. And so we're going to have refugees that are going to be forced to move inland. Now we're talking just here in the United States as an example, but think about all of our island populations throughout the world. Think of all the other countries where they have areas bordering the ocean. All of these are going to be impacted. We've got Venice in Italy already is having to build things to like keep the water out. You have your, if you have an island that's like pretty flat, it's 30 feet above sea level, it's going to be underwater in the somewhat near future. And so, yeah, we're using the United States as an example, but this is going to be like all the places that are bordering the ocean. Now, additionally, we're going to have these disease vectors. Now, remember that vectors are going to be things like mosquitoes that are going to carry diseases and infectious diseases that can be passed on. So things like mosquitoes, ticks, fleas, they can transmit these diseases from human to human or from animal to human. So some of the diseases that we talked about in Unit 8, things like malaria, Zika virus, West Nile, dengue fever, cholera, these are all going to be vectors that mosquitoes are going to be able to pass. Now, as the temperatures warm, we are going to get an expanded range from these. The warmer temperatures are going to allow insect-transmitted diseases to spread to parts of the world where they were previously too cold. So if they tended to stay kind of near the equator because that's where it was warm, that's no longer going to be the case. They're going to be moving farther and farther, which means it's no longer just going to be these areas that are at risk for malaria and Zika and West Nile. It's going to be pressed up into areas where we have not had that be a danger. Now, as the insect vectors expand their range further from the equators towards the poles, this is going to put more and more people at risk of all of these diseases. And again, some of them can be treated with antibiotics, but some of them are like very serious. Like Zika, it results in babies with deformed heads, and we don't have a cure. So we're having even more and more populations are going to be at risk from these if the mosquitoes can spread. So this right here is going to be a map of our current, this is a specific type of mosquito that is the vector for dengue, Zika, and yellow fever. So if you look, as I talked about, red is going to be how often we see them here. So like for the entire year, we see them around the equator. Parts of the year, they end up farther north. So this is where it is right now. This is where it is going to be in 2080. As you see, it is like greatly, like here in the Seattle area, we're going to be getting this mosquito when we previously were not in only like 60 years. And so this is clearly going to be spreading much farther than it previously was. And with all the diseases that come with that, that is a problem. Now, if you look at these maps, this is why we talk about greenhouse gas emissions. And this is why it is important for us to not continue with our increasing temperatures. Now, on the right-hand side here, this is what it would look like if we just kind of kept going at the rate that we are. On the left, this is based on the Paris Agreement goals, which we'll talk a little bit more about the Paris Agreement in future notes. But essentially, it's this global agreement where countries are working on decreasing their greenhouse gas emissions. So if we decrease our greenhouse gas emissions, which will lead to less of those molecules that are going to be radiating the heat back, this is a more favorable change in the range. It's still not as great as where it is right now, but like it's better than if we just don't do anything. And this is why dealing with greenhouse gases, why it matters that we decrease it. Some people might be like, okay, well, it's cool if Seattle maybe gets a degree Celsius warmer because like it's cold here a lot. Even if you like slightly warmer weather, it's like way more complicated than that. We're talking about diseases spreading. We're talking about islands being wiped out. We're talking about coastal communities that will no longer exist anymore. Even like on the coast of Western Washington, we have cities and village and like areas that will be taken out because they will be underwater at the rate we're going. So like these are kind of all the reasons why it's not just as simple as, oh, it's cool, it's going to be a little bit warmer. There's a lot more that goes into it from a environmental perspective, but also like from a human health perspective. All right, so this is going to be your practice FRQ for 9.4. I want you to look at this diagram here, which if you notice the title, it says malaria by 2050. I want you to identify a region where malaria rates may increase by the year 2050. Make sure that you're paying attention to the legend down here. So again, identify a region where malaria rates may increase by the year 2050. Then explain how climate change may contribute to this increase in malaria in this region. So that is going to be your practice FRQ for 9.4, and those were your notes on 9.4.